What you see here is the first ever picture of a black hole. This particular black hole is situated at the center of the M87 galaxy and is found to be 53.49 million light years away from Earth, and it was pictured by the brilliant team at the Event Horizon Telescope project. But aren't black holes simply black voids in space? How do you see something that dark? There seems to be a way, and let's find out how. The term black hole was first used by an American scientist, John Wheeler, to help us gain a more visual understanding of these objects. Right, so they're black. Why exactly are they so dark in the first place? Based on Einstein, space can be expressed as a fabric known as the space-time continuum, a mathematical model that fuses the three dimensions of space with the dimension of time. Any object with mass generates its own gravitational field, and this creates something that looks like a valley or a well on this fabric of space and time. The greater the mass, the larger the gravitational field generated by it, and hence the deeper the well it creates. Based on the wave-particle duality of light in quantum mechanics, that is, light can behave as both a wave and a particle. If light is to be considered as a particle, they would be affected by gravity just like a tennis ball, a pebble, or a rock. Therefore, when light is under the influence of a black hole's extreme gravitational field, it would be pulled in, hence light cannot be emitted or reflected off of a black hole. But isn't all about light reflecting off of objects and landing on our eyes the basis of seeing things? So we still can't see a black hole. Turns out we were looking at the wrong part of the electromagnetic spectrum. Since gas from nearby stars fall towards the black hole, the gas spirals, like falling down a water slide. As a result, these particles rub together, resulting in friction and heat, producing X-rays. But we don't detect X-rays because as these rays travel towards Earth, and since a black hole is situated hundreds and thousands of light years from Earth, their frequency reduces and wavelength increases. By the time the waves reach Earth, they've been elongated to the size of radio waves. Detecting the waves is yet another challenge. Consider multiple radio telescopes situated across the globe. The Earth's curvature and the absolute location of a black hole will mean that the radio waves emitted by it would be picked up at different times by the different telescopes. However, a method called aperture synthesis allows us to combine the radio information from each telescope to form an instrument with the combined size of all these telescopes. Each individual telescope records a timestamp of when it received the radio waves. This, along with many other pieces of information, is passed on to a supercomputer known as the correlator, which maps this information to form a single image. This picture reminds us about the commitment of scientists, and that any accomplishments, regardless of its magnitude, can be achievable given determination and teamwork. And also that seeing is believing.